Uh, Hi guys, so today we'll be solving Leetcode challenge nth magical number. So a positive integer is magical if it is divisible by either a or b. So given the three integers and a and b, we need to return the nth magical number. So you can take a look at this example. We need to return the first magical number of 2 and 3, and that's basically 2. Okay, so the second magical number will be 3. Third magical number would be 2 plus 2 is 4, right? And vice versa. So the first thing coming to my mind is actually using heap. And as you can see here, I use heap, and it causes memory limit exit, since I'm pushing a lot of number into our min heap. Although I has a visited set to keep track of duplicate number, it doesn't have, right? So I need to come up with a solution that doesn't using too much memory or space, and basically I use binary search for this. So the lower bound could be the minimum of a and b, and the upper bound could be the maximum a and b multiplied by n. So what do I mean by that? So the n number cannot be larger than the maximum of a and b multiplied by n. Why is that? So if I get 3 multiplied by 1, I will get 3, right? So as you can see, the first magical number is 2 is smaller than 3. Why? And this is basically true for every scenario. If I get the maximum of a and b, and then I multiply by n, I basically get the magical number for that, for b only, right? For b only, because for example, if I need to get the magical number of 3, the third magical number of 3, I basically do 3 multiplied by 3, that's 9, right? And then if I take into account, and now I need to find the magical number of 3 and 2, there's gonna be some number in between, right? 2 is gonna contribute something to that sequence, for example 2, 4, 6, 8, right? So hence, if we take the larger number and we multiply by n, we're going to get the upper bound. And then after that, what are we going to do? We get the lower bound, get the upper bound, we're going to get the midpoint, right? So for every midpoint, we are going to need to find out how many numbers are below or equal to the midpoint from a and from b. We do that by actually calculating how many numbers from a's are directly below or equal to the midpoint, right? We can just do some basic math, and from b point, right? And then in between these numbers there's going to be duplicate. And how are we going to do that? We are going to use least common divisor, right? For example, for 4 and 6, the least common divisor is going to be 12. and hence for every 12 unit they're going to collapse, they're going to meet each other every 12 unit. So we need to minus this guy out, because basically they are double count. You can see 4 plus 4 is 8, 8 plus 4 is 12, right? And 6 plus 6 is 12. So if I get 2 plus 1, I'm going to get 3, but 12 is double count, so I'm going to get 2. And for every midpoint, if the midpoint has the number of number that is below it is smaller than n, then we are going to set our left pointer to mid, to keep exploring new mid plus 1, to keep exploring new potential candidate that could lead to potential higher end. And then if else, we're just going to set our right pointer at mid, right? Okay, so that's basically the approach we are going to do it. First, we are going to implement to init our mod left right pointer could be equal to min a and b max a b multiplied by n, right? Our least common divisor is going to be a multiplied by b divided by the greatest common divisor between a and b. Then while L is smaller than R, the mid could be L plus R divided by 2, and then the smaller from A could be okay, so here's a quick a hint, like a tip to optimize your runtime, because there will be cases where A is equal to B, and in these cases you can basically just return A or B multiplied by n, right? So if A is equal to B, just return A multiplied by n, and that's going to make your runtime a little bit faster. A smaller from A could be equal to mid minus mid A so the midpoint is not always going to guarantee that it's going to divide A entirely. So you guys need to find the upper bound of the midpoint that is going to divide by A, right? So this is how we are going to do it. We are going to find the modulo of mid and A, and then we get mid and subtract it, right? Subtract it from mid, and then we are going to get a point in between where we can safely divide by A. Okay, so smaller from B is going to be mid minus mid B divided by B. And then now we need to find the upper bound, could be equal to the min of the upper bound, which means the smaller point of these two guys, right? Because now we are going to calculate the items, the number that is double count. So we need to find the range in which the guys are overlap, and it will run basically from the least common divisor to the minimum between these guys, right? So I'm just going to copy and paste these guys here. Okay, so overcount will be equal to basically the upper bound minus basically the same thing as above, and then divide by LCM, right? And then if smaller from A plus smaller from B minus overcount is actually smaller than n, then we are going to set our left pointer to mid plus 1, else we are going to set our right pointer to mid, right? And then at the end we're just going to return L mod. Okay. Okay. I'm going to submit it, and as you can see is very efficient, right? I beat 100% in runtime. So what's the time complexity of this? The time complexity is basically O log of min AB and then max AB multiplied by n. And the space complexity is actually O1, since we only need to maintain a left and a right pointer, right? And that's it for today, and I hope you guys understand the solution, and see you guys in next video.